Hi there, so we are now in Math 2. So in this section, we will be solving different kinds of equations. So let us first recall a few terminologies. So number one, roots or solutions of an equation. So these are just the values of x that satisfy the equation. So meaning to say all you have to do is to solve for x. When you collect all of those values in a set, that is now called a solution set. Now, take note that in problems that require you to solve for x, if the choices are nice, what do I mean by nice? The choices are integers, you can use substitution to see which value will satisfy the equation so that there will be no need for you to solve the equation. So that will save you more time. For instance, we have this, solve for x. And take note that this equation is not quadratic. This is actually cubic. It's actually um, more difficult, right? So it's either you will have to use synthetic division and so on if you will solve this. However, if you take a look at your choices, the choices are just -1 or 1. So why don't we just substitute these values? So let's try first -1. So for letter A, if we have, let's substitute x equals -1. So we have 0 is that equal to -1 cubed minus 2 times -1 squared, 3 times -1 minus 2. So this is -1. Take note, PEMDAS, you have to square first your -1. So you have minus 2 times 1 minus 3 minus 2. So that's -1 minus 2 minus 3 minus 3. Even if I don't continue, I know that they are not equal. Na? This is not equal to 0. So -1 can be part of the answer. So hence, we can easily eliminate A and C. So let's now try x equals 1. So when we substitute it, 0 is that equal to 1 cubed minus 2 times 1 squared plus 3 times 1 minus 2. So we get 1 minus 2 plus 3 minus 2. So we have 1 minus 2, -1 plus 3 is 2 minus 2. So we really get 0. So the answer is letter B. Okay? Let's now solve linear and quadratic equations. What are linear equations? So linear equations are equations of the form mx plus b equals 0, or meaning to say the highest exponent of x is just 1. If the highest exponent of x is 2, then you call that a quadratic equation. So these are the steps in solving quadratic equation. So first step, set one side to 0. So that is really important, no? Set one side to 0. You cannot proceed to step 2 without doing this first step of setting it to 0. Why is that? Because we will be using the 0 property, which says that if AB is equal to 0, or if the product of two numbers is equal to 0, that means that one of them, at least one of them, is 0. You can only do this if one side is 0. So that's why for the next step, you factor the non-zero side, and then equate each factor to 0. If it's not possible for you to factor it, then you proceed with the quadratic formula. Now again, this is your warning. Never factor one side of a quadratic equation without setting the other side equal to 0. What I mean by that is, for instance, you have, let's say, x squared minus 2x equals 1. And then you will factor this when this is not yet 0. So you have x minus 2 equals 1. And then, what will you do now? You cannot do anything because this side over here is not equal to 0. Okay? So let's discuss this example. So we have a quadratic equation here, and then find the values of x. You can actually solve this, but for me, what I will just do is substitute since the choices are nice. It's what I mean by nice. It's just 0, 4, or negative 4. So if x equals 0, when I substitute, I get 3 squared equals 25. Obviously, not true. If x is equal to 4, we have 4 plus 3 squared. Is that equal to 6 times 4 plus 25? So this is 49. This is also 49. So 2 is true. X equals negative 4. So we have negative 4 plus 3 squared. That equal to 6. 6 times negative 4 plus 25. So this is 1, which is 1 also. So right. So the answer is 2 and 3. So it's letter. Next, find the solution set of this one. Now, note that this is not really a quadratic equation because the highest exponent is not 2. We have 4 here. However, although this is not a quadratic equation, it is quadratic in form. Why is that? Note that the variables that appear here, you have x squared and x to the 4. Okay, if you look at the bigger term, the x4 is simply the square of x squared. So if you have something like that, it's quadratic in form. Another example would be if you have x6, x cubed, and then a constant. So that will tell you that it's quadratic in form. Okay, so how do we proceed? So first, let's turn it into a quadratic equation. So let u be equal to the variable with the smaller exponent. And then, if that is the case, x4 is now u squared, right? So when we substitute, we now get u squared minus 2u minus 15 equals 0. This is now just easy to factor. This is u minus 5, u plus 3, which means that u is 5 or u is negative 3. However, remember that we are solving for x, so don't forget to substitute. U is x squared. Here, x squared equals negative 3. But take note that x squared equals negative 3. Is that possible? That's not possible, right? This is impossible because the square of a number cannot be equal to a negative number. So that leaves us only with x squared equals 5. So therefore, x is equal to plus or minus square root of 5. If the quadratic equation, the non-zero side, you cannot factor it, you can use quadratic formula. So this is the formula. X is equal to negative b plus or minus square root of b squared minus 4ac over 2a. It's really important that you memorize this formula by heart. Okay? Now, let's look at the sum and product of roots. So if you have a quadratic equation, there are always two roots. So let's say that's R1 and R2. The sum of the roots is equal to negative b over a. So remember that a always refers to the coefficient of x squared, and b is the coefficient of x, and c is just your constant. And then the product of the roots is equal to c over a. For instance, what is the product of the roots of 25x squared minus 9? Without solving for the roots explicitly. So recall that the product R1 times R2 is equal to C over A. What is C in this case? C is negative 9 over RA is 25. So the answer is letter B. Next, let us discuss the discriminant. So the discriminant tells us the nature of our roots. Now, our discriminant is b squared minus 4ac. Now, I have here your quadratic formula. So this discriminant actually appears here inside your square root sign. What will happen if b squared minus 4ac is positive? So it says here that you have two real roots, right? Because if you look at your quadratic equation, all right, so you will have two answers, right? If it is equal to 0, you only have one real root, because if that's the case, your x will just be equal to negative b over 2a. One real root only. What will happen if b squared minus 4ac is negative? So you cannot have square root of a negative number, right? It does not exist in the set of real numbers, correct? So if that's the case, you have no real roots. However, it also means that you have no real roots, but you have two imaginary roots. Okay? Now, let's look at this case where we have two real roots. What will happen if b squared minus 4ac is a perfect square? Meaning to say the answer to your square root of b squared minus 4ac is an integer. So for example, in my quadratic formula, I have negative 1 plus or minus. My b squared over 4ac is 4. And then let's say my 2a is 2. So if that's the case, since square root of 4 is an integer or 2, the answer for x is a rational root. Whereas if it is not a perfect square, the answer that you will get is an irrational root. Okay? So let's look at this one. The roots of the equation 5x squared minus 2x equals negative 3 are, okay, you have these different choices over here. So we first have to get the discriminant. So, but before we do that, we need to identify our A, B, and C. But remember, before you get your A, B, C, one side should be equal to 0. So we have 5x squared minus 2x plus 3 equals 0. So let's now look at our discriminant, b squared minus 4ac. So my b is negative 2 minus 4. My a is 5 and c is 3. So we get 4 minus 60, negative 54, meaning to say it's less than 0. So if our discriminant is less than 0, what kind of roots do we have? Letter A, imaginary.